Good morning, grade 11s. Today we are going to continue and conclude our chapter on arrays. So we have covered so far bubble sort, selection sort, as well as linear and binary search. And today we're going to look at sorting and searching in parallel arrays. Now, a parallel arrays, just as a form of introduction, an example would be, and I think I've mentioned it before, is if you have a text file with authors and titles of books that they have written, and you read that information into two separate arrays. One array with author name and the other array with book titles. The advantage of is that you can now sort these arrays according to either alphabetical book titles or alphabetical authors. And you can extract information from both arrays in that way. However, if you, after you've read in the information from the text file into these two separate arrays, and you sort the one array, let's say the authors, in alphabetical order, and the author is now in a different position in the array than it was originally, then the corresponding book title in the other array will be in a different position. So if you find an author in the author array and position 5, the book in position 5 in the title array does not match. So we are going to look at an algorithm that enables us to sort the one array and keep the corresponding titles or corresponding elements in the other array in the same position as the new sorted array. So let's open our textbook. So sorting and searching in parallel arrays. Okay, we're going to move all that. I've mentioned this already. So here in the example that they're giving, they actually have learners' names and corresponding marks. So James got 70%, France got 56, etc. Now, if I would sort this alphabetical, and Andy would be in the first position, Andy got 65 and not 70. So how am I going to sort this array, but also apply the same sorting into, for the second array? So the algorithm would look like this. So we apply, and I agree with that. I would use the selection sort. I prefer that, but you can use the bubble sort as well. That is up to you. But within our loops, we have most the nested for loops. This one is the for loop is omitted in the example that they're giving here, but you still have that. And then you ask the question, if r names k is bigger than r names l, then begin, and we do the swap. We do not ask again. So we're sorting now our names array. But the T marks or R marks term 1 also needs to be sorted according to the same criteria. So if a swap happens in this array, we will apply the same swap in the second array. So regardless of whether the mark is bigger or not, so we're not going to ask this this question for the second array. We ask it for the first array, we do the swap, but we also do the swap in the second array. And that is literally it. So if you know these couple of lines of code, you know how to sort a parallel array. So the index values of elements of the parallel array as well as its contents are associated with one another. Therefore, you only have to search for an element in one array and then use the index value to find the other information from the array regarding the element you found. So if I search for the name, and I find it in position 5, then I can use that position to extract the mark out of the second array. And that's it, guys. We have concluded our chapter on arrays. So what I want you to do today, this was short and sweet, activity 7, and as you can see, that concludes our chapter. And then once you have completed that, you can use the rest of the time to study for tomorrow's assessment. All right, guys, I hope this was helpful.